What's acid in the first place? What's acid? Acid is any substance that contains hydrogen ion. Hydrogen ion. Okay, remember we learned about elements. We learned about elements: hydrogen, and helium, lithium, beryllium, boron. You name them. We learned this. These elements have some atomic particles, subatomic particles. They have electrons, they have protons, they have neutrons. They have these three subatomic particles: electrons, neutrons, and protons. And we said that electrons and neutrons are found in the nucleus of the cell. In the nucleus of the cell. So if this is okay, let me try to draw something here. Okay, let me add another slide here. Okay. Okay, if this is the atom, at the center we have the nucleus. In the nucleus we have what? In the nucleus and if this is the nucleus, okay, if this is the nucleus and these are the shells, in the nucleus, which are the center, in the nucleus we have protons and neutrons. They are called nucleons because they are found in the nucleus. Electrons are found in the shells. They are found in the shells. Protons are positively charged. Their charge is positive, but electrons are negatively charged. Protons are positively charged, so proton positively charged. Electron negatively charged, so the E is negative, right? So negatively charged. Neutrons, they have zero charge. There's no charge for neutrons. So in a stable proton, in a stable atom, the number of protons and the number of electrons are equal. So we have the number of positives and the number of negatives are equal, so they cancel each other out. Therefore, the overall charge of the atom is zero. It's neutral, no charge. It's neither negative nor positive, so it's neutral. Yeah, the overall charge is neutral. The overall charge of the atom is neutral. Then the question comes: why do we call hydrogen? Why do we call hydrogen proton? Yes, that's the point I want to come to. That's why I'm explaining all this. If we have hydrogen, if this is hydrogen, it has one positive proton here and one electron which is negative. Now it's neutral because and as well a neutron does not have a charge, right? There's a neutron as well. So the overall charge of hydrogen as of now is zero. because the number of positives and the number of negatives are equal. So they cancel each other out. So the overall charge is 0. Okay. Now, when hydrogen loses this electron, it has only one electron. When it loses this electron, it becomes what? There will be no electron, right? There will be no electron. There will only be neutrons and protons. The only charge it will have will be positive. The only charge it will have what? It will be positive because there are no negative electrons. It lost the electron, so there is no electron, and it went with this negativity now. So the only thing left with us is proton, which has a positive charge, right? And now, because it does not have electrons, they call it proton. That's why we have the H plus here. It lost the electron, so it's it lost the electron. So sometimes they call it the hydrogen proton, right? Hydrogen proton, because it lost the electrons. It lost the electrons. It lost the electrons, right? It lost the electrons. So hydrogen ion. There are many acids that we come across in our daily life. You will see acids on daily basis, right? On daily basis. These acids are in our foods, car batteries, and used in industrial processes. So all the foods we eat, there is some sort of acid. There is some sort of acid, right? Because we eat fruits and vegetables in which there are a lot of acids, right? Some of these acids are found, are listed in this table, and where they are found are listed in this table. So we have citric acid, ascorbic acid, hydrochloric acid, acetic acid, tartaric acid, sulfuric acid, nitric acid. There are so many others, like tannic acid. Okay, citric acid. So this is where it is found. Citric acid is found in lemons. Lemons. I think you know the difference between lemon and orange. They are different, yeah? Orange is linmaan. Lemons is lindanan. You know it, right? So lemons is rich in citric acid, right? Citric acid. There's a lot of citric acid in lemons. Ascorbic acid, it's found in fruits and vegetables. Ascorbic acid is vitamin C, right? You know vitamin C. Sometimes you can buy it from the pharmacies as a tablet, right? As a tablet, right? Ascorbic acid. So it's all the fruits, almost all the fruits and vegetables that we use at home have an ascorbic acid or vitamin C. Hydrochloric acid. Hydrochloric acid is found in our stomach, right? In our stomach. In our stomach, there is a very strong acid. It's called hydrochloric acid. And sometimes it can be manufactured industrially, right? It can be industrially manufactured. Acetic acid. Acetic acid is found in sour milk. In sour milk. In the sour milk, like yogurt or so on and so forth. So acetic acid is found in this milk. Tartaric acid is found in grapes. In the grapes, grapes. Yeah, tartaric acid is found in grapes. Sulfuric acid, it's found in car batteries. This is actually industrially produced. It's not natural. Yes. All the others are natural, but the last two, nitric acid, which is found in fertilizers. Fertilizers are these things that we use to make the soil of our fields very rich and productive, to be fertile. Fertile. Fertile means productive. So for us to grow in whatever we grow, if you want, for example, to grow tomato or potato or sorghum or maize or this and this, the soil in your field should be very fertile. Sometimes the soil loses its fertility one way or the other, maybe because of over-cultivation, sometimes maybe overgrazing. You did this in social, right? So sometimes it loses its fertility. Sometimes it loses its fertility. So to bring that fertility back, we use fertilizers, industrially produced fertilizers that make it rich and productive again. So they are made up of citric acid and explosives. You know, these big explosives that sometimes you see Al-Shabaab exploding somewhere. So they make these explosives out of nitric acid. Uh, all the explosives are not made of nitric acid, but nitric acid is always part of it. It's not the only thing that explosives are made up of, but it's part of it. It's part of the things that explosives are made up of, right? So nitric acid. Okay, I think you understand. So we have citric acid. We have citric acid, which is found where? In lemons. We have ascorbic acid or vitamin Z. It's vitamin Z. Or vitamin Z. Vitamin Z. Vitamin Z. This is vitamin Z, right? This is vitamin Z. It's found in fruits and vegetables. All the fruits, lemons, orange, guava, avocado, you name them, right? And vegetables like onions, cabbage, spinach, kumaweki, you name them, right? Hydrochloric acid. Hydrochloric acid can be natural, as in the one of the stomach. Our stomach produces hydrochloric acid. That's why I always advise you against chewing gums. For example, when you start chewing gums, your stomach the moment you move your jaws and teeth and try to chew something, the signals to your stomach telling that there is something coming from the mouth. So it starts producing hydrochloric acid. That's why you feel hungry when you eat gum, because there's nothing you're eating, you're just chewing something, right? Okay, so it kills the bacteria. It makes some of the proteins like vitamin B12 active. It also makes iron absorbable. So it does actually a lot of work um, for the stomach, for the body. Lactic acid. Lactic acid is in the sour milk. You see the word lactose, lactic. It has something to do with milk. Tartaric acid is found in grapes. Sulfuric acid is found in carbohydrates. Nitric acid is found in fertilizers and explosives. You have to commit this table to your memory, right? Yes, it's a very useful table. Types of acids. Types of acids. We classify the acids into two: natural acids or organic acids, right? Natural acids or organic acids, yeah? Natural acids or organic acids. Acids found in fruits, vegetables, milk, stomach, etc. are called natural acids. These include, why do we call them natural acids or organic acids? Because they are in the nature, they are in the natural things, they are in the fruits, vegetables, milk, stomach. No one has made this one, right? Right? It's Allah's, only Allah has created these things. We don't industrially produce fruits, vegetables, milk, stomach. That's why we call it what? Natural. Okay, so some of the acids are found in these natural things like citric acid. Citric acid is found where? I have you know it in lemons, ascorbic acid, vegetables and fruits. Lactic acid in milk, tartaric acid grapes. Tannic acid, it was not in the list. Tannic acid, it's found in tea. Tannic, tea, right? So these are natural acids or organic. They mean the same. Organic acids and natural acids, they mean the same, right? They mean the same. They mean the same, right? They mean the same. Another type is laboratory acids or inorganic acids, right? Laboratory acids or inorganic acids. These are acids produced and synthesized in the laboratory, are called laboratory acids. These are called laboratory acids. They are processed and produced in the laboratory, in the industry. Yes. These acids include hydrochloric acid. Hydrochloric acid can also be natural, right? As in the stomach acid, right? Sulfuric acid, which is found in carbohydrates. Nitric acid, which is found in explosives and fertilizers. These acids are very strong and corrosive. Corrosive means they can cut things into pieces. For example, if you take a piece of cloth or metal or whatever, paper, and put in the acid, in one of these acids, it will be dissolved, right? It will be completely dissolved. They can damage the skin. That's why it's corrosive and clothing and should be washed immediately with water. Yes. If you come in contact with one of these acids, you have to immediately wash it off by using running water, tap water, right? By running tap water, right? So hydrochloric acid, sulfuric acid, hydrochloric acid, sulfuric acid, nitric acid. These are laboratory produced acids. The acids in the food taste sour. Unripe fruits are more sour than ripe ones because they have more acid. This is because the ripened fruits contains more sugar than unripe ones. Properties of acids. So for you to call a substance acid, it has to have these properties. It has to taste sour, right? When you taste it, it has to be sour, right? Acids are soluble in water. Yes. If you mix them in water, they will dissolve. Some acids conduct electricity, so they conduct electricity. So if you put a piece of wire, an electrified piece of wire in water and in acid, and you dip your finger in, you'll feel the electric shock. Acids react with bases to form salt and water. There are substances called bases. We will see in our next lecture. There are certain substances called bases. We'll see them in our next lecture, right? Acids turn blue litmus paper red, right? What does acids do? They turn the blue litmus paper red. So litmus paper is a small paper, right? It is of two forms. One is red and one is blue. If you have a substance which is as clear as this water and you don't know whether this is a paste or acid or neutral. Neutral means it's neither acid nor paste. It's not acid, it's not paste, it's called neutral. So when the substance is clear as such, we don't know whether it's it's acid or base or neutral. We take maybe, let's say, blue litmus paper. We dip it in. If it turns red, if it turns the blue litmus paper red, it's what? It's acid. If it does not change the color and the substance and the litmus paper remains blue, it's either neutral or it is base. Then we take the red litmus paper to classify whether this is base or neutral. We dip it in. If it still remains blue, it is neutral. But if it turns the blue litmus paper into, and red litmus paper into blue, it is base, right? It's base, okay? So these are the properties of acids. It tastes sour, it's soluble in water, it conducts electricity, it reacts with acid to its bases to form salt and water. Salt is milh. Acid is 10 litmus paper. Right. So these are the properties of acids. You need to know them, right? Uses of acids. Acids have some uses. That is not hydrochloric acid. That is not hydrochloric acid. This is sulfuric acid. This is sulfuric acid. Huh? Uses of acids. Sulfuric acid is used in car batteries, right? Sulfuric acid is used in car batteries, right? Sulfuric acid is used in car batteries, right? Phosphoric acid is used to remove rust. Rust is dahl, you know, when the metals become rust. To remove them, we use what? We use phosphoric acid. Acetic acid and ethanoic acid is found in vinegar. Vinegar is khal, which is found in additives. Vitamin C is ascorbic acid. Yes, I said this in the beginning. Vitamin C is ascorbic acid, so it's used as a vitamin. Ascorbic acid is used what? As a vitamin. Yes, it's as a vitamin. Acetic acid and ethanoic acid is found in vinegar. Okay, citric acid and benzoic acids are used as food preservatives to prevent your food from spoiling. For example, if you cook some food and you want to keep it for a while, you can add citric acid and benzoic acids. And usually the canned foods have citric acid and benzoic acid as preservatives. They preserve it. They preserve it means they prevent it from spoiling, right? They prevent it from spoiling, right? Hydrochloric acid is used for metal cleaning before electroplating. You know, electroplating. Electroplating is when you want to prevent a metal from getting rust, to get it rust means dahl. We put some other metals on top of it. So before doing that, we clean the metal that we want to electroplate. We clean it. So we use hydrochloric acid to clean it. Household cleaning, normal house cleaning, it contains hydrochloric acid. Because we have chlorine bleaches. Chlorine bleaches are derived from hydrochloric acid because hydrochloric acid is made up of chlorine and hydrogen, right? Leather processing. Yeah, when we are making leather, leather is mass, right? When you remove the hides and skins from animals and you want to turn them into useful products, and you are taking them into the industry, usually we bleach them in hydrochloric acid, right? Hydrochloric. So these are the uses. Use of acids. Nitric acid is used for production of fertilizers and explosives. We explained this at the beginning. Tartaric acid, which is from grapes, is used for soft drink production. So some of the soft drinks are made of grapes, by the way. Okay, that's the end. That is the end. Thank you very much. Let's summarize what we have said. We started talking about acids. So it's any substance that contains hydrogen ion. Ion means when the atom loses or gains electron, it becomes what? It becomes ion. Now in our case of hydrogen, it usually loses the electron. There are many acids that we come across in our daily life. These are examples of acids: ascorbic acid, lemons, which is found in lemons; ascorbic acid, which is found in fruits and vegetables; hydrochloric acid, which is found in the stomach; lactic acid, which is found in sour milk; tartaric acid, which is found in grapes; sulfuric acid, which is found in carbohydrates; nitric acid, which is found in fertilizers and explosives. There are two types of acids: natural acids. Natural acids, they are also called organic acids. They are found in fruits, vegetables, milk, stomach. They are called natural acid. This includes citric acid, found in lemons; ascorbic acid, found in vegetables and fruits; lactic acid, found in milk; tartaric acid, found in grapes; tannic acid, found in tea. This is found in tea. No, this one. This one is found in there's also another type of acids called laboratory acids, inorganic acids. Acids produced and synthesized in the laboratory are called laboratory acids. These acids include hydrochloric acid, sulfuric acid, nitric acid. Hydrochloric acid can also be natural because it's found in our stomach. These acids are strong, they're very strong and corrosive. Corrosive means they can cause damage. They can damage the skin and clothing and should be washed immediately with water if you come in contact with them. The acids in the food taste sour. Unripe fruits are more sour than ripe ones. This is because the ripened fruits contain more sugar than unripe ones. These are the properties of acids. Acids have sour taste. Acids are soluble in water. Some acids conduct electricity. Acids react with bases to form salt and water. Acids stain blue litmus paper red. Use of acids. Sulfuric acid is used in carbohydrates. Phosphoric acid is used to remove rust. And acetic acid and ethanoic acid is found in vinegar, which is a food additive. Vitamin C is ascorbic acid. Vinegar is the hull we use, right? Citric acid and benzoic acids are used as food preservatives. Hydrochloric acid is used for metal cleaning, before electroplating, household cleaning, leather processing. Nitric acid is used for production of fertilizers and explosives. Tartaric acid is for soft drink production. Okay, thank you very much.